Okay, thank you. So I'm going to talk about honesty in cryptography, partly because we're building zero-knowledge proofs. I've researched zero-knowledge proofs from many decades now, and it's a tool to make participants honest in protocols. And I do think that we need honesty in crypto. But I also want to talk about how I think I'm really been a naive cryptographer, and maybe zero-knowledge proofs is not the solution for everything. So let's see if I can make this clicker work. There we go. Okay, so I'm going to give a couple of not so hot takes. Unlike I'm very risk averse. So I'll make the claim that I do like cryptocurrency, and I think it's better than the fiat currencies. I do think that Web3 and DeFi has the potential to be better than the traditional financial tools. I guess the only hot take I really have in this context is I'm not so fond of stablecoins, because I think that's really tying us to fiat currencies rather than real cryptocurrencies. But also not so controversially, right? There's a lot of work left to improve crypto. And one of the things that we are working on at Nexus to improve the crypto is we're thinking about how to make everything verifiable. So you can have things like proving solvency, that somebody actually has a positive amount of funds. You can use things where you prove things about identity and know your customer and these kind of things. You can prove that transactions have been executed correctly. And so in general, we would like to build something which we call verifiable finance. Okay, let's try to make everything related to finance verifiable. And we have a great ambition beyond that. We would like to make everything verifiable, and we've used the taglines verifiability at internet scale. Okay, so this is a starting point, but kind of want to take a little step back and think about this from a cryptographer perspective, right? So what we're really building on, and the reason I'm doing this is because there are some things that are just hard to prove, right? So if you can say, hey, this is evidence that you were deviating from the protocol, you can use zero-knowledge proofs to prevent that. You can prove that you followed that protocol. But there are many things that don't lend themselves to that. In particular, things about actions people have not taken, right? Then you can't really prove anything about that, right? Maybe you're just waiting for them, and it was a communication failure. Maybe it's deliberate that they didn't do something. Confidentiality is also hard to prove anything about, right? If somebody leaks the secrets, it's can't really use proofs to that. So I'm probably been too optimistic in the past when I thought that zero-knowledge proof would make participants honest. Okay, it makes them honest in some aspects, but it doesn't cover everything of honesty. So we need more things, and in crypto, if you look at what are the models we use to prove that protocols are correct, right? It's taken from cryptography, and cryptography you might see something like in a multi-party computation protocol saying that, hey, we have a bunch of nodes. Some of them honest, some of them are corrupt. Okay, and there are various words you can use for that. And I think this is an imprecise model. And I think it's also, if we think about it, zero-knowledge proofs, it's not so clear what we're really proving here. What we are really trying to improve is maybe compliance, right? Rather than somebody's honest or a moral judgment that they're good or bad. So let me give an example of where I think we lose a bit of precision, right? So if you think about one of the early works about how should we formally reason about, say, a protocol like Bitcoin and why it works, right? Talked about chain quality. Okay, so they said we have some honest parties, we have some corrupt parties, and then chain quality says, roughly speaking, that the amount of blocks that get minted by an honest worker is proportional to the working capacity of this set of honest workers. And you sort of like then implicitly deduce something, well, if they're honest, then they're doing good things for the world, whatever that may be, and the paper didn't say anything about that, right? But you could think of, like, for instance, maybe we want censorship, resistance, and fairness, and things like that. Something like, if it's an honest worker, then it would include, users according to fair criteria in the blocks. And I think it's imprecise, okay? I think a more real definition would be that maybe we have some alliances of nodes or something like that, okay? And every alliance sort of gets to create blocks at a fraction that's sort of proportional to their computational power. And from a user perspective, the chance of getting included, it's not so much of a, it's honest or not, more it's like, is it a friendly worker, right, that will include their transaction? And maybe what friendly really means that is that, it accepts your fee for inclusion. Right? And it's not hard to see that the first definition actually does imply the second one, right? But I do think that it would be nice that if we can be more precise about what we actually mean. And I think maybe it's sort of like the original way that cryptographers have been thinking about this that's leading us a bit astray. Okay, so I was talking about zero-knowledge proofs, right? And I think the nice thing about zero-knowledge proofs is that it can be used to enforce compliant behavior, right? So suppose you have a protocol and every participant has to prove that what they did is according to the protocol, right? And you get some, from the zero-knowledge proof, the soundness means that now we are ensure that the actions are compliant, and then zero-knowledge means that, the honest nodes here, right, that their information, their confidential information doesn't get disclosed. And I have been saying very publicly, something like, well, this ensures that the nodes are honest. And I think that's also a bit wrong, right? Because there are things where zero-knowledge proofs and verifiability is not sufficient. Okay, so let me try to give a couple of examples of that, which are very pertinent to blockchains in general, right? So in the old school, maybe you would have a chain, you would recompute everything, ensure it's compliant. If you think about a more modern protocol, maybe you would do something like, give a proof at the last block. So this was something Mina pioneered, right? That, all the way from Genesis to this last block, there's sort of like a legitimate path of actions that would result in this particular state. Okay, and now we have something that we can give any user, and they can just verify this proof, and it's very cheap to verify whatever they want to know about then transactions, right? So everything is verifiable, everything is great. And I'm going to shoot myself in the little foot because at Nexus we are really trying to talk about verifiability is so great. But there are some things that you can't do with zero-knowledge proofs here, right? So one thing is omissions, right? I mean, if there's a missing block, well, you can't really prove that there's no next block that hasn't been disclosed yet. Okay? You can also have faults, maybe forks, right? So if you have, say, multiple valid branches, somebody's trying to do a double spending attack or something like that, perhaps, right? If these are legitimate, both of these chains are legitimate, you could prove both of them are correct, right? But it should just be one that gets used in the world. So for that thing, I think I'm going to go now. Past I've said crypto means cryptography, but I'm going to go the other way around now. I do think there's a difference between crypto and cryptography. I think crypto is about the real world, the reality that we have in the systems we build. And I don't think it matches very well necessarily the cryptographic models we have of bad behavior in the system. And I think this is important that we think about how we model and which kind of assumptions we make about the world. We model that better. And in some cases, it really gives us an advantage. and can give us better results than you just have with the traditional cryptographic model, right? And so one example of this, I mean, if you think about the standard reasoning when you have like either nodes are completely honest or completely corrupt, right? Then you would say something like, we can prevent forks if 2/3 of the stake is honest. Okay. If you think about rational actors instead, and this is something that Ethereum has built into the protocol and has been formalized by Buttigieg and others, then you can actually show that there's an incentive against forking, even if you just have 1/3 of the stake, which is at risk. So by modeling the world better, we can also get better properties. Okay. One thing that annoys me, and this is why I'm presenting it here, I think it's sort of like the frontier of reasoning about security of crypto, and I think there's a lot of work for us to do there, and we're sort of like just starting to scratch the surface, right? But one thing, I mean, in their result is that they still have to assume at least 1/3 of the stake is compliant. So not in fully, completely just, we'll look at the economic incentives and nothing else, right? There's still an assumption, and there's still a question like, why should that be true? So, as I showed, I also think that the way cryptographers have been thinking about attackers, and I think this is because, well, in a cryptographic protocol, if you can prove it against the strongest possible attacker, one that controls all the corrupt parties, then sure, that's great, right? But the reality is that in some systems, and I think in crypto, you're leaving something on the table if you sort of like go with that model and then try to prove something instead. So let's sort of like fit the model to the situation, and we may get better proofs. Okay. And one thing I didn't talk so much about, I think it's also very dangerous to think about these nodes as single entities, either they're corrupt or not, right? I mean, what if a node has a bug in the software, right? Is it corrupt? Is it not corrupt? Well, in some sense, we would just say it made a slight deviation. Okay, it's corrupt. And if you look at real systems, right, then what you have is actually organizations that are running sort of like systems of nodes and so forth, right? And it's quite different from just being corrupt or not corrupt. Okay, so I think I'll wrap it up here. I just want to sort of like give a shout out. I think it's, I didn't realize that beforehand, but I think actually SpaceComputer really is addressing the question I'm raising here, right? They're sort of like coming up with a new security model for the systems and the machinery that we're building crypto on. So I think that's great. And with that, thank you.